Now let's look at the graph of greatest integer functions. How do we go about graphing greatest integer functions? So we want to graph few of them. The first one says we must graph y is equals to the greatest integer of x. So like we normally graph linear function, we have our x and our y. We have x value, and then we put x value within the function to get our y value. That's the same way. So let's say now we have let's select some numbers, some smaller numbers, some bigger numbers, meaning some negative numbers, some positive numbers for this function. So let's say x is equal to 0, and then you put 0 here. Because 0 is a whole number, now let me draw the line again so that you can forget. 0, 1, and then 2. 1, and then 2. So when x is 0, the greatest integer of 0, which is now an integer, it just equals to 0. So when x is 0, y is also 0, right? Now, what if x is, let's take some smaller decimal numbers. What if x is 0.25? 0.25 is between here, right? Assume that we have 0.25 right here. But let's say 0.2, 0.3, 0.2. So 0.2 is between here. Now, what is that whole number that is not more than 0.2 and it is the greatest among all the other whole numbers? And it should be an integer. So all of these are all integers, right? And because these are all integers, the greatest of these integers is 0. So 0 now is the greatest integer for 0.2. So if you have x to be 0.2, you have our y to be 0. What if you have x to be 0.3? 0.3. The same thing, right? It should not be more than 0.3, but it should be less than 0.3, and it should be the greatest of all integers. So if this is 0.3, it means the greatest integer to 0.3 is just 0. What about 0.4? The greatest again to 0.4 is 0, right? What about 0.6? The greatest to 0.6 is also 0. You are not rounding number up. Remember we said the greatest integer should not be more than the number. So it should not be more than 0.6. It should be that integer that is less than 0.6. It's like the immediate integer that is to 0.6. So 0.6 is 0. So lastly, what's about 0.8? It's also 0, right? Okay, now let's take some decimal numbers. Let's say some negative numbers. What if we have negative 0.2? So if it is negative 0.2, that immediate integer, greatest integer to 0.2, that is not more than 0.2 is minus 1. Because we should not cross 0.2, so it's minus 1. So this is minus 1. Even if we take 0.5, negative 0.5, it is still minus 1. Even if we take negative 0.8, it is still minus 1. So let's say we say positive 1. When x is positive 1, y will be positive 1. Right? When x is negative 1, y will also be negative 1. While when x is 2, y will be 2, right? Now let's work with these guys. Because normally the step function, there is a pattern that you normally follow. So let's look at the graph. So this is 0, which is the origin. Now this is 1. This is 2. So we have this to be 1. We have this to be 2. We have this to be 1. We have this to be 2. This is also 1. And this is 2. Okay. Now let's graph now. When x is 0, y is 0, right? Where are this origin? When x is 0.2, 0.2 is on this axis. This is x, this is y. When x is 0.2, so we look for 0.2. So let's say between here now, exactly between here is 0.5. So 0.1, 2, 3, 4, 5. So this is it. So 6, 7, 8, 9, just like that. So between here also is 0.5. Between here is 0.5. So this is negative 0.5. So this one now 1, 2, 3, 4. 0.1, 0.2, 0.3, 0.4, 0.5. So it's also 1, 2, 3, 4, and so forth, right? So when x is 0.2, this is 0.2, 0.1, 0.2, y is also 0. So right there, right? When x is 0.3, y is also 0, so it remains here, right? When x is 0.4, y is also 0. When x is 0.6, y is also 0. When x is 0.8, y is also 0, right? So you have a long line. You have a long line that is between 0 to 1, but 1 is not part of it. So it is closed at this point and it opens at this one, right? Now, the next one you have negative 0.2. So this is how we have negative 0.2, 0.1, 0.2, and then what is our y? Our y is negative 1. So if this is negative 0.2, y is now negative 1, right? Down here. So let's say this minus 1. Now, so just around here like this, right here, right? Directly here like this. Okay. That is it, right? When x is negative 0.2, y is minus 1. When x is negative 0.5 now, negative 0.5, 0.5 here, y is also minus 1. Y is also minus 1. When x is negative 0.8, negative 0.8 is this one. What happens to y? Y is also minus 1. So you see that? Now, when we have minus 1 here, when x is minus 1, when x is minus 1, y is minus 1. Minus 1, right? Okay. So you observe that there is a kind of straight line from this point all the way to minus 1. Similar to the one we have here. So we draw a straight line into this. Now, we can close this one because we know that when x is minus 1, y is minus 1, right? But we do not have wherein x is let's say some 0, then y is minus 1. No, we don't have that, right? When x is 0, y is also 0. So we do not have this point. So we open this one. This one is not part of the solution. So we open it right there. So this is closed and this is open. So it's open because it's not part of the solution. Likewise, this is closed and this is also open. It's not part of the solution. You see that? Now let's look at one case. When x is positive 1, this is positive 1, right? What happens? Y is now positive 1. So when x is positive 1, y is positive 1. So right here, right? Positive 1. So you see, this thing, you have 1 unit between here. Now it escaped 1 unit here, it drops down. So in this case, now we're going 1 unit downward, like this, so 2. Then we're gonna have a long line like this. So that pattern will continue. It closes right here and it opens right here. That pattern is going to continue. It closes here, it opens here. So this pattern is going to continue. This one, it closes here, it opens right here. It opens right here. Then you're going to move up again, up to like 2. Move up to 2, it closes at 2. Then it moves in this direction. It opens at this point. Now let's prove it. When x is 2, y is 2, right? When x is 2, y will be 2. So this is the step function that you will have. Something like this. Now why we call it a step function? Because you claim a step, right? You claim the first step, you move upward, you claim another step, you come upward, you claim another step, you come upward, you claim another step, and so forth. So this is how we graph greatest integer function that we also refer to as a step function. Very, very easy to graph.